Hello everyone. Now that we have covered interfaces, abstract classes and virtual classes, all three, it is very common confusion that when to use which one and how to decide whether we should go with the interface or whether we should go for the virtual class or whether we should go for the abstract class or what are the common difference between them so that we can decide which one to use. So intention of this video is to clarify all those things with the help of an example. First, I have already created three classes, basically one interface and one abstract class and third virtual class. Now we will go for a quick refresher on what interface does, what abstract classes does, what virtual classes does, and then we will pick one. We will do a critical analysis on why we chose interface for this, why we did not choose abstract or virtual. Similarly, when we go through abstract, we will see why we did not use interface or why we did not go for the virtual class here, and for virtual we will do the similar analysis for the abstract and interface. Okay, so first thing first, we have created an interface. This is nothing but a trigger handler example where an interface will contain the methods which are required by any trigger in your Salesforce, or be it trigger for contact, be it trigger for opportunity, be it trigger for account. It will have these methods: before insert, after insert, before update, after update. I have chosen just four, but they'll be for delete as well and for undelete as well. Okay, now why do we use interface? Interface is like a contract. It only defines what must be done. Now it does not care about how that thing will be done. So in your trigger, in account before insert, logic will be completely different from opportunities before insert. So the code implementation or how to do certain thing is completely dependent on which object we are talking about, right? But both account trigger and opportunity trigger, they'll have the before insert method. So with the help of interface, we will say, okay, every trigger in your org will have a before insert, after insert. What you do inside this is up to you. With the help of interface, we just gave a contract that any class which will be using this interface, which will be implementing this interface, will have to provide body for the before insert method and after insert method, similarly before update and after update. But what you want to do inside that is completely up to you. That is why we write the interface. It just contains the method signature. Okay, and it cannot contain any common code or any common logic. It will just have the method signature. That is why we created an interface. Now why we did not go for abstract and virtual, we will talk shortly. Let us understand our abstract class. Now why we chose the abstract class or why we have written an abstract class is because, see, every abstract class is like a halfway between interface and the normal classes. Abstract class can contains both the abstract method and normal method. Okay, so abstract method will just have the method signature and your normal method will also have the body. So whenever you have a scenario where there is some common implementation which will apply to everything, like let's say for account, opportunity and contract trigger, there is a common way to log the errors. So it will apply to all the objects, whereas the actual logic inside the before insert and after insert is applicable or is varies based on the object we are talking about, right? So common implementation we can write inside the generic methods, and anything which we want to have a specific use case depending on object, we can write as a abstract method. So abstract method gives you a flexibility that you can have both abstract method and normal concrete methods, and uh, depending on what you want to do inside it, you can have some common logic in your concrete methods as well. And all those abstract methods must be overridden by the helper methods which you will be using or which will be extending this particular abstract class. So abstract class is somewhere in between interface. Interface just gives you method signature, whereas abstract class gives you method signature functionality, as well as there is a feature by which you can also have a concrete method as well. So any common logic which applies to every object you can write in the concrete method, and that will reduce the code. Because let's say you create trigger for contact, opportunity, account, and you will have to log errors for all those objects, right? If you will not use the concrete method here, you will have to rewrite the same logic again and again in every trigger. But if you will use this structure with the help of abstract class and concrete method, you need not to rewrite it again and again. You will be able to reuse it again and again in every trigger object you want to use. Okay, so it will reduce the code. It will provide you a structure as well. Like this abstract method, any helper class, let's say account trigger handler. Account trigger handler has to provide body for the before insert and after insert. If it will not provide, the compiler will throw an error. So for logging, you already have the code written, but for before insert and after insert, you will have to provide logic, otherwise compiler will throw error. So it provides a structure, or it enforces a structure as well. All right, let's go back to our third example, which is a virtual class. Now, why we chose virtual class? First, see, the virtual class will be actually doing the before insert and after insert, and it will have the logic inside it. In virtual class, you cannot have just the method signature. No. Virtual class methods inside the virtual class or the virtual method has to have the body, and there is additional feature that you can override these methods. So virtual class says that I will give you some default logic. Okay, so I am giving you some default logic inside this before insert. If you want to use it, very good, just use it. But if you have some additional functionality, or if you want to override this behavior, or if you want to write your own logic, then extend me and write your own logic on it. Okay, so override is possible with the virtual method, but if you do not want to override, compiler will not throw any error. Okay, so if you will by default use this logic is already there. This is not just the method signature, but it will also have the structure inside it. Okay, so virtual class will give you this feature. Okay, now override is optional. It is not mandatory. It is not necessary that if you have written a virtual method, you will have to override. No, it is just an optional thing. If you have certain things which you want to do additionally, then you can override it. Otherwise, default implementation is already there. You can use that, and if that satisfied your need, then there is no need to override. Okay, compiler will not throw any error. Remember, in the virtual class, there will be no such feature that you can just declare a method with method signature without any body. No, you will have to provide real body inside a method. That can be overridden if somebody wants to do that, but it has to have some body inside it. Okay, it cannot just be method signature. So those are the virtual classes. Now we will go back to our interface again, and let's do some critical analysis on why we went for the interface here. Okay, so I'm again on my interface. First, understand why we chose interface, and then we will talk about why we did not choose virtual or abstract. Why we chose interface here is because we just wanted to enforce a contract that each handler, let's say opportunity trigger handler, account trigger handler, contract trigger handler, each trigger handler must provide the methods for these signatures we have written. We just wanted to enforce that every trigger written in our org has to have body for these methods. Okay, so with the help of interface, we are enforcing that contract that you have to have body for these methods. Even if you don't want to do, let's say there is a trigger where we do not have anything to do on the before update, make it empty, but you have to have a body, because in future you may write something inside it. We are already giving you a structure so that you can scale it further. So In the beginning, you'll have to provide the body. If you don't want to do anything, maybe just keep it blank, but have to have body so that in future also you can scale it further. So this is interface is doing that for you. Okay, it makes your framework very consistent and structured because every handler will look same. Now if you go for opportunity trigger handler, then also you know that there'll be four methods: before insert, after insert, before update, after update. You go for contract, you go for code, you go for quote line item, whatever, whichever trigger you go through, you will see that it has the same structure because you are using the interface. So it enforces the structure. It provides you a contract that every handler need to follow this structure. That is the advantage. That is why we are using interface here. Now why not the abstract classes? Why we are not using abstract classes here? If we see again, the feature of abstract class is that it can provide you abstract method which can have just the method signature, and if there is any common logic, we can also have a concrete method which has the body. Now here if you see interface, we do not have any common logic, right? So there is no common code written here. There is no need for any common code. And if we use abstract here, then we can have abstract, we can have just the method signature just like that. But that will be an overkill because the problem is that we don't have, first we don't have any shared logic, so there is no need for concrete method. So if we make it abstract class, then we will only have the abstract method with just the method signature. And then also there is a problem that if we just go for the abstract method without any logic, and later on in future if we need to have any common or shared logic, then your whole trigger framework need to be restructured. Okay, just for the contract purpose between class and the parent class and the child class, we cannot go for the abstract class, because abstract class in future we may have something where we need to add some common logic. In that case it will fail. Also, do not think it from the point of view of whether we can do this or not. More than thinking about whether we can do this or not, think about, is it a good way to do or not? There are n number of different ways. Let's say if we have to do it anyway, then there is no need for even interface, abstract classes or virtual. You can have the normal generic classes. For every object you will write different classes and you will do that. But is it a right way to do that? Is it a good structure? Is there any scalability? Will you be able to promote reusability? No. That is a very static approach where every class has its own structure. There is no common structure in your org. There is no reusability. There is no flexibility. There is no scalability. So rather than thinking about whether we can do this or not, think about, is it a right way to do this or not? With the abstract class, we can definitely replace the interface. Okay, but because with the interface multiple inheritance is also allowed. So let's say your class is following this I trigger handler for trigger. Let's say there is a error logging framework, there is a call out framework, you want to implement them as well. In that case, interface will allow you to do that. You can also follow the structure of error logging, you can also follow the structure of call out. But if you go with the abstract classes, multiple inheritance is also not allowed. So then in that case you will have to have different classes and different structure, and that will completely break your code. So with the interface you can also have multiple inheritance as well. Plus uh, plus if you go with the abstract class here, that abstract class will not be scalable as well, because then in future you will not be able to add the common logic in it. And then if you need to add, you will have to restructure the entire framework. So interface is best here for this use case, because you just needed a contract between the parent and child class. That child class need to provide body for these method. And I just told you that why abstract class is not a good way to do that, because first there is no shared logic. So abstract class's main advantage is to have the shared logic written inside the abstract class. Other, abstract class does not allow multiple inheritance. Okay, so in that case, if your child class need to follow a particular framework or structure via different interfaces, interface will do that, but abstract class will not do that. So that will not be a good design framework if you do it with the abstract class. Can we do it or not? Yes, you can do that. Is it good? Of course not. It is very bad approach. Do not do that. Okay, it is interface which is suitable in this situation. Now, why we did not go with the virtual class here? Let's go and see virtual class again. What is the feature virtual class provide? Virtual class provide you some default implementation, plus it also allows you to override this behavior if you want to have some specific implementation for certain use cases. Do we need anything like that here? No, we do not even need anybody. All we need is a contract that child class need to provide the structure. We do not need any default implementation at all. If we use virtual and just write some if we just use virtual and write some default implementation, there is a risk that default implementation will run that code and that might not be needed. Or if we do it with the virtual anyhow by tweaking our code, then there is a risk that child class might not override the default behavior when it was needed, and compiler will not even throw the error because those overrides are optional and your code logic may give you wrong results as well. So virtual is not needed here at all. Do not try to break it by unnecessarily trying to overdo things here. We just needed a contract, and that is why the interface was the best possible way to do that. We can do this with the abstract classes with just the abstract method, but that will have certain disadvantage that it will not allow multiple inheritance. There is no shared logic, so the real use case of abstract class will not be used. So abstract class will not be useful, and virtual class of course will not be useful because we do not need any common implementation. Okay, and there is always a risk that if we use virtual and if our child class will not override it, we may run our code differently and we may have a risk of getting the wrong results. Now coming to the abstract class, I know this might be a bit complex. Just revise other just if it is bit complex to you, just think of it, slow down, ask your doubts in the chats or put some comment. I'll definitely try to even make it more explanatory, but we cannot go with generic examples of student, dog, cat, because this is Salesforce specific design thing. I understand it is bit complex, but I want you to focus more on this. Revise again what is virtual, what is abstract, what is interface, relate it with this example, and then I'm very sure that we'll be able to understand this. If not, I'll set up some common doubt sessions for all of you. Just let me know if this is a bit complex and I'll try to make it even more clearer. Okay, now let's come back to our abstract class. The feature of abstract class is that it gives you some shared logic. It gives you a flexibility to have concrete methods as well as the abstract method. In the concrete method, you can have some shared logic like trigger execution, like log execution, like you can have some certain common way of sending emails, or anything which is common or which is needed in all the cases you can do in the concrete methods. Now why we use abstract classes here? Because now we have some common logic, like some utility methods like validation. So here we have a common logic to log the trigger execution. So because now we have some common logic, we can write that common logic in the concrete method, and we still want our child classes or the child handlers, let's say account trigger handler, to provide body for the before insert and after insert. So for that we have the abstract method. So it gives us both the advantages: shared base functionality and mandatory override for the certain part. So mandatory override for your abstract method. So because it gives us both the functionality, it's a best way to use the this is the best place to use the abstract class because we have some common logic to share as well. Now, why we did not use interface? See, interface can't contain any code inside it. So you will not be able to have body for your shared logic. So interface is out of equation. Interface is not suitable at all for anything where you need some body inside your method, because interface will not allow you to do that. Okay. So interface we cannot do. Okay. If you have to do it with the interface, then what will be done? You will have to have a log trigger execution method signature there, and every handler class will then need to provide body inside it, and that will be the duplication of code as well. We don't want that to happen. Okay, so interface is not a suitable use case for this particular scenario. Abstract class is a better use case because it gives us both the feature. Now let's talk about why we did not use virtual here. We could have used virtual, and we could have had the common logic inside the default implementation, and for other methods like before insert and after insert, we would have provided some basic common implementation, and because we can override it anytime, that would have made it a perfect use case, right? No, actually with virtual there is always a risk, because it already provides the default implementation. It is necessary, or it is very important that child class override the method. Now here, because virtual class will have some basic implementation already, but for before insert and after insert, every handler will have a different logic. There is no basic implementation, or there is no basic common method or common logic inside the method. So virtual class will not a very good fit here. If you try to fit in virtual here, let's say you write log triggered execution in the basic implementation, and for before insert and after insert you just give some very basic common implementation, and then you allow your child to override it, because compiler does not force the override of these methods. So if let's say a opportunity trigger handler does not override the before insert, and there is just basic common implementation written here, then in that case just basic common implementation will run, but it will not override anything. So the actual implementation which you needed to run for opportunity trigger handler will not run. The problem is that compiler will not even force the implementation or will force the override, because that is optional. So there is always a risk with virtual method that if your child is not overriding, compiler will not throw the error. Your code will not run, just the default implementation will run, and that will produce you wrong results. Okay, so that is why virtual is not a very good use case here. If you try to fit in, you will be able to fit in somehow, but that will not be the ideal use case. So always think of it in such a way that if you have some common implementation, plus you also have some methods on which you just want to provide body, but you want to allow child classes to provide the actual implementation detail, then go for the abstract classes, because it gives you both the features. Okay, interface and virtual is not a good fit for use case like this. Okay, now let us come back to our third, which is the opportunity trigger handler. This is a virtual class. First, let us discuss why we use virtual here, why virtual is a good use case. Think of it like a scenario. Okay, in most of the scenarios, the default behavior or default setup or the default implementation which you write may be fit 90% of the time, but there will be some cases where the default implementation you give inside a method will not be sufficient. You might need to extend it, you might need to add some additional logic in it. Let's say this is opportunity trigger handler, it works very well for all the opportunities, but then you have a concept of split opportunity, or let's say you have a concept of special different type of opportunity for which before insert trigger is bit different, but for rest of the opportunity it is same. So in that case you can have a virtual class where you will have a virtual method. Inside virtual method you will write everything, but then you will also have a child class which will be, let's say, split opportunity trigger handler, that will override the before insert written inside the opportunity trigger handler and will write its own logic. So for 90% of the case, the before insert written inside the opportunity trigger handler will work. But for a special type of opportunity, we will use the split opportunity trigger handler and we will extend the method written inside the opportunity trigger handler. Okay, because the virtual method allows you to override it, you will easily be able to override it. Plus, because it is optional, you need not to override it for all the cases. So for 90% of the cases, you need not to even override it. The default implementation will be sufficient. But for rest of the 10% of the cases, you will override it and you will use the split opportunity trigger handler method written inside that. Okay, so virtual is a very useful in such kind of situation where you have multiple executions and you have different ways to deal with same thing, and that is not mandatory for you to override. So it depends on when you need it and when you don't need it, and it is up to you when you want to override it, when you don't want to override it. Compiler will not force you to override it. So developer or you need to write your logic in such a way that if it is an split opportunity, then you do override it. Okay, because compiler will not force you to do the override. Okay, there will be no compile time error if you do not override this virtual before insert method. Okay, if you need it, then you will override it, otherwise you will not. So virtual class is a very useful in such kind of situation. Now let us understand why we did not use interface here. See, interface force every method to be implemented in the child class. If we use interface and just give the method signature, every child class has to provide body. Even if the logic is same, then every trigger handler has to provide body for it. That is nowhere related to our use case, what we are doing here. So interface at all is not required. We cannot do anything like this with the help of interface. And interface, if we use, that will definitely be increase the code, and you will have to write extra code, which will obviously reduce the flexibility, increase the rigid behavior of your code. Will not be using interface at all. Now why not abstract classes? That is a very good question here. See, in some situation child classes don't even need to override it. If you go with the virtual if you go with the abstract class, you know that you can write some common implementation and then you can have some abstract method. But if you have the common implementation, then that will be used, that cannot be overridden. And if you have the abstract method, then that will not have any body. So both of these situations will not help our use case. Our use case is that if you want to override it, then you do that. If you don't want to, just use whatever is written. So this kind of flexibility is not available in the abstract classes, and that is why abstract classes will not be a perfect fit for this kind of situation. Okay, so with this we have covered abstract classes, virtual classes, and interfaces. And I completely understand that this is a bit tricky topic, bit complex, and it tests you on different level. I will highly encourage you to ask your questions in it, because I understand this is a bit complex, and it is very common to have confusion on why we did not use it, what will happen if I do this. Just remember my point, that it is not about doing something whether we can do it or not. It is about, is it a right way to do or not. Okay, because when we talk about good design, why we build a trigger framework? To have a good design. Why we do all these thing, we can have just simple normal apex classes and do that, but that is not a good approach in a long run. Okay, so think of it from the point of view of whether is it a good approach to do this or not. Okay, not from the point of view that whether will be able to do it or not, because there are n number of ways of doing certain things, but not all are the good ways. Okay, and I'll wait for your questions on this topic, because I know this is a bit complex, and I'll be more than happy to answer all of questions. Thank you. I'll see you in the other videos. Goodbye.